What is polynomial and what is the point of learning it? How important is the skill of solving polynomials? Do you know that polynomial is the building blocks in many mathematical expressions, and it has many useful applications in modeling and rendering objects? Obviously, it is also an important topic to master if you want to score well in your maths exams. Welcome to the first session of this polynomial series. In this video, we will introduce some important concepts and the basic operations of the polynomials, including long division through 5 worked examples.
Hello, Math Champions! I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything. Welcome to the series of polynomial. This is the first session of this important topic. Now, what is polynomial and why we need to present this topic? Why the skill of solving and tackling polynomial is important? Well, polynomial is an algebra expression consisting of variables and coefficients. It is used in nearly every field of mathematics to express numbers as a result of mathematical operations. It is building blocks in other types of mathematical expressions, and it is also very useful for modeling and rendering objects. As we know, polynomial is made up of two terms, namely poly, meaning many, and nominal, meaning terms. A polynomial is defined as an expression which is composed of variables, constants, and exponents that are combined using the mathematical operations such as addition, subtraction, multiplication, and division. The degree of a polynomial is defined as the highest degree of a monomial within a polynomial. Thus, a polynomial equation having one variable which has the largest exponents is called a degree of polynomial, as shown in the table. Here, A, B, C, D, and E are all constants. A is the leading coefficient, and the term not containing the variable x is called the constant term. A monic polynomial is a polynomial whose leading term has the coefficient 1. Since polynomials can be transferred to monic polynomial as shown on the screen, we will mainly focus on monic polynomial in our later study. The operations of polynomial, such as addition and subtractions, are naturally defined. What we can add or subtract are like terms. Here are two examples, one for addition and the other for subtraction. As it can be seen that px plus qx equals 3x cubed minus x squared plus 3x minus 16, while px minus qx equals negative x cubed minus 3x squared plus 3x plus 6. Alternatively, we may line up all the like terms vertically, just like we do addition and subtraction with natural numbers. Finally, we have to say that it is a good practice to place all the terms in parentheses before performing addition or subtraction, particularly to the expressions that are subtracted. To multiply a polynomial by a scalar, we multiply each term of the polynomial by the scalar. In example 2, we multiply each term of the polynomial px by negative 2, which results in negative 6x to the power of 5 plus 4x cubed minus 6x plus 2. To multiply two polynomials, we multiply every term of the first polynomial by every term of the second polynomial, and then collect like terms. In example 3, we multiply every term of px by every term of qx, which results in 2x to the power of 5 minus x to the power of 4 minus 8x cubed plus 6x squared plus 3x minus 2. Polynomial multiplication can also be performed using the coefficients only. This kind of multiplication is called synthetic multiplication. In this way, we detach coefficients and multiply as in ordinary multiplication of large numbers. As for the previous example, we detach the coefficients 1, -2, 0, and 1 from px, starting from the leading coefficient and downwards. Since there is no linear term in px, the linear coefficient is 0 in this case. As for qx, because the leading term in qx is a quadratic term, so we place a 0 in the cubic term. Then we performed multiplication with the coefficients of px and qx, and then obtained results as displayed on the screen. The division of polynomial can be performed by simplifying polynomial fractions, or can be proceeded in a similar way like we do for division of whole number. Example 4 here demonstrates a division procedure of a polynomial of 2x cubed plus 7x squared plus 10x plus 15 divided by the term of x plus 2. Since the denominator is x plus 2, we try to make such a term on the numerator. So the quadratic term of 7x squared is separate as 4x squared plus 3x squared. Accordingly, the linear term of 10x is also separated as 6x plus 4x. And the constant 15 is also separated as 8 plus 7. Then we partially factorize the numerator to make the term of x plus 2 as a common factor of all the terms except the constant 7. After taking out the common term of x plus 2, the numerator becomes x plus 2 in parentheses multiplies the quadratic trinomial of 2x squared plus 3x plus 4, or in parentheses plus 7. After separating all the terms having x plus 2 from the constant 7 in the numerator, the entire fraction can be separated as two parts. In the first part, since both numerator and the denominator having the term of x plus 2, they can be cancelled out. So the result of such a division is 2x squared plus 3x plus 4 plus 7 over x plus 2. Here, the quadratic trinomial is the quotient, and 7 is the remainder. Example 5 shows the same question exactly as example 4, but it demonstrates a different division algorithm which is very similar to what we do with the whole number division. As it can be seen from the picture, the first step is to find a term with which we multiply by x to get 2x cubed. So 2x squared is such a term we need. Then we have terms of 2x squared times the sum of x and 2, which equals 2x cubed plus 4x squared. As for the second step, after subtracting 2x cubed plus 4x squared from px, we bring down 3x squared plus 10x plus 15 from px. The third step is to find a term with which we multiply by x to get 3x squared. So 3x is the term we need. After subtracting from 3x squared plus 6x from the remaining term, from the second step, we obtain 4x plus 15. The next step, which is not showing in the diagram, is to find a constant with which we multiply by x to get 4x. So the answer is just 4. Finally, we obtain the number 7 as the remainder of this division. Now, in general, if a polynomial px is divided by a linear term ax plus b, its remainder can be calculated by just replacing the polynomial variable by negative b over a. As for example 5, in order to calculate the remainder when divided by x plus 2, the number negative 2 is substituted into the polynomial variable, and we can work out the remainder, which is 7, as we did in the previous example. Now we look at the division of polynomial by a quadratic factor. In this case, the remainder can be either a linear factor or a constant. Example 6 is such a question. The polynomial x to the power of 4 plus 4x cubed minus x plus 1 divided by x squared minus x plus 1. As we did in the previous example, the first step is to find a term with which we multiply by x squared to get the term of x to the power of 4, which is x squared. After subtracting x to the power of 4 minus x cubed plus x squared from the polynomial, we obtain 5x cubed minus x squared minus x. The next step is to find a term with which we multiply by x squared to get 5x cubed, which is 5x. After subtracting from 5x cubed minus x squared minus x, we obtain 4x squared minus 6x plus 1. The last step is to multiply a number 4 by x squared to cancel out the term 4x squared. After subtracting 4x squared minus 4x plus 4 from the bring down terms, we obtain the remainder of this division, which is negative 2x minus 3. In summary, the quotient of this polynomial division is x squared plus 5x plus 4. The remainder of this polynomial division is negative 2x minus 3. Sometimes it is useful to express a polynomial as a divisor times the quotient plus the remainder. If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.